Alrighty. Hello, everyone. Okay. Alright, so this is our team. For those who don't remember my name, I can say it again. My name is Alejandro. Here to my left is Solimar, and to my right is Emily. And we came up with, I don't say came up, but our experiment was about comparing radiation shields and to see which one resists temperature, I guess heat, the best. So objectives for this little experiment is we're trying to develop a more cost-effective version of this radiation shield that you see on the screen here. So what these radiation shields do is just they measure air temperature and they try to block the UV radiation from the sensor. So
Also wind. That's why it's kind of a
Yeah.
tiered
Good one.
vein design.
Yeah, and then also we wanted to apply the knowledge that we gained from this workshop and apply it in real-world applications. And then, as I mentioned earlier, identify which material, because we use two types of materials, that has the highest resistance to heat and wind. Was I explaining this one?
This is the setup that we had. We tried two different materials. We put a sensor in the middle, and then we measure the response to it. We had also a control sensor in between those two, and we plot the results. Emily's going to talk about what we found.
Oh, we still got the theme of
This
consideration.
is also part of the instrumentation we use. We use the box developed by Limanji Physical, and we use a computer, a Raspberry Pi computer, with connected to a screen and connected to the lab jack. The lab jack was connected to the sensor that we have, to the hardware, and with this we use it to save all of the information that we later plot.
Actually, see here. So inside the two white cylinders, those are actually our shields. The internal stuff is another group's project. But inside each of those is a thermistor. So that uses resistance and correlation with temperature. So these are the results of temperature in Celsius. We were able to calibrate to room temperature and actually got numbers that weren't completely out of bounds potentially for what ran. So we were able to run until midnight. So we got 2 cycles out, and it looks like the peaks are when the lights were on, and then when they were off, cycled down. So green is our control thermistor that was outside of the shields, and then our orange is the ASA material, and the purple is the ABS material. So as you can see, the ABS, so the purple material got a lot hotter, a lot faster, while the ASA got a lot cooler. However, it looks like the response time of both of them to heating up and cooling down is actually pretty sharp. So when the light's off, they actually cool down pretty quick.
Thank you for your time.
All right, questions, thoughts, comments? Yeah, so wind is pretty much this area here, I believe. Yeah, so one cycle was kind of a rough cycle. I think one cycle was every 5 hours. Yeah. So it was kind of playing with the different variations. So maybe the first hour is like maybe no light, no heat, and then kind of just every hour then turn on a light source, turn off the fan, and then next hour turn on the fan, turn off the light. Yeah. So I guess in this case, let's see, 1653, 1753. So it's 1 hour here. So I think we had the lights on in this first hour, and then yeah, I guess we should have marked that down a little better. When I think I had a picture of it too. Yeah, so basically this is probably when the lights are off and the fan was on. And so you can see that our two materials had a very similar response to when there was no light, and the wind or the fan was the only one that was on at the moment. So this is what this little period here represents. And then anything beyond midnight, there was a software update, and it kind of gave us useless data, so we had to take that out. Yes?
What's the biggest challenge in making that sensor?
Trying to figure out how to put it together, I would say probably the biggest challenge. But then this unit was a voltage divider, and so once we figured out how to kind of put that in this lab jack here in red, then it just got easy, got more, not less complicated.
You need to look at the data sheet to figure out it's a voltage divider.
No, we kind of
So the
John kind of mentioned it as well. So we're like, okay, it's voltage divider, and then Jonah helped us out with the configuring this setup as well.
The data sheet for this actually could not be located, so I think it was ChatGPT or Google provided the coefficients for the formula,
Yeah.
which actually did a pretty good job. We got reasonable temperatures, so
So was your control shaded
Yes.
underneath, or was it out in the?
no, it was actually shaded under one of our sensors. So even our control was not truly accurate.
That's probably why it was not heating up as much.
Yes,
Yeah.
and actually got quite a few like flutters, or you can see like the spikes or the issues in there.
Okay.
The green signal here, but yeah.
Could it blow, like when the fan came on, do you think it was moving the control? Is that what?
I actually was hoping it would, that we would see that, just to see if it was actually responding.
Yeah, that's not, can't really
but-
see that enough. Yeah.
It's so small wiggles.
I would
It's a
say.
little noisy anyway, so just have to
I
talk.
would say if there was some type of maybe blowback, there might be some resonance in the signal, but it's not really obvious here.
Other questions?
Yes,
What was your favorite part of making this whole
building it pretty much. Yeah.
Did you do any machining?
No, we didn't really do a lot of machining.
We
No,
did not have to just attach it.
we just put it together and then wire it, configure it, and yeah, that was it.
So what did you use to put it together? Is it like glued together?
Bolted. It's just bolted together.
Yeah.
Yeah, just tapped some holes and we're able to thread screws and nuts.
You need to solder the wires, right?
Yeah, we did some wire soldering as well.
The original sensor wire was not long enough, so just added length.
Do you think that added any noise to your measurement?
The amount of length we added, I don't think so. Again, it's kind of hard to tell, but I think the sensors were noisy, just in the
General,
environment.
yeah.
Because the signal was also very, very small. So like very, very small voltages. I think we're looking at a range of like 5 volts. So
Besides, we did the calibration at the end, after putting the wire at the end of the sensor. So we calibrated for that. Yeah.
So
yeah,
if you-
good point. We did.
If you wanted to calibrate these to absolute temperatures, it's like you actually knew for sure that it was
Yeah.
41 instead of, okay, that seems close, and like they're all relative. Like, what are some of the ways you might calibrate it to be absolute temperature?
So what we did for this, just to get to like close temperatures that actually held pretty
sense.
decently, is at the final configuration of it, like where it was at, took a temperature reading like of the room and then looked at the voltage that we got and just applied that one offset to it. But the correct way, and this should probably answer your own question, was to use like a heat chamber to actually like isolate and then ramp up and compare the voltages to the I guess the heat there, because it's truly probably not a linear relationship.
Anybody else?
How
All
did
right.
you guys go about finding the resistance of the thermistors you guys were closing?
You measured?
Yeah, I did. Say that question again, sorry.
How did you guys figure out the resistance of the thermistors you were using?
You measured.
Yeah, okay, yeah. So, go.
Okay, we have 10 kilo ohms resistor, and with that we measure first the resistance of the sensor, and based on that we found a similar resistor that we control. We knew the exact value that we were going to have. Then we connected that one with the sensor, and we measured the variations on that resistance due to the effect of different temperatures. So each temperature will give us different voltage values that will be measured by the resistance on the circuit. And we look at the different values as a function of time. And yeah, that was pretty much how we did it.
Yeah, I did a lot of conversions to get temperature.
Anything else? All right.
Cool.
Okay.